Today's video is going to be about solving linear systems with a graph. This is lesson 34. Make sure you are following along in your guided notes.
So here's our old example, and we're going to talk about what a solution to a line means. So here's our line, and if we were trying to create the equation, we'd say like, oh, this is our y-intercept, or in other words, if we have a table of values, this point is 0 on the x-axis, 2 on the y-axis. So 0, 2 is a solution to the line because it falls on the line. The same thing is true about any point on this line. So this point and this point. So this point is 1, 2 on the x-axis, 1, 2, 3, 4, 5 on the y-axis. That's a solution. Negative 2 on the x-axis. Negative 1 on the y-axis, that's a solution. And then all these other points in here, these are also solutions. They're a little trickier to write because we don't have an exact value. I mean, that looks like it might be half. So negative 1/2. But any point on this red line, anywhere here or here, anywhere that we want to look, these are all solutions to the line. An example of not a solution is a point over here. That's not a solution to the line because it's not on it. Not a solution, not a solution, not a solution, not a solution. What about right here? What about right here? Solution or not? That is a solution because it lies on the red line. So with that in mind, let's jump into our next style of examples.
Okay, so we know what a solution looks like when we have one line on a graph. It's any point on that coordinate line, or that coordinate, on that line. Any coordinate point on that line. Sorry, it took forever to get that one out. Now, when you have two linear equations graphed on the same coordinate plane, what does a solution look like? Well, if a solution to this line is any point on the line, what is the solution to both of the lines going to be? It's going to be a point that both of the lines share. So if you look right here, here's a coordinate point that both this negative sloped line and this positive sloped line share. So how do we write the solution to this? Well, we just type it as a coordinate point. So what is that coordinate point that they both share? Well, it's negative 7 on the x, and it's 5 on the y. And we can go ahead and type that in. Negative 7 on the x, and 5 on the y.
So again, here's our next example. If I'm looking at these lines, I know that any point on this line is a solution to this line, and any point on this line is a solution to the lower line. But I need to know what's a solution to both. And right here is the only place where they both meet. So that is 2, 4, up to 9. So here's 8, this line is 9. So I know that this is the coordinate point 4, 9, and I can enter that down here. This last example is an example of parallel lines. So what do you know about parallel lines? Just think about that for a moment. Well, parallel lines never intersect. So lines that never intersect. If the lines never intersect, where do they intersect? That question should sound weird to you. If the lines never intersect, where do they intersect? Where's the point where they actually intersect each other? Well, we can't find it because they never intersect. That's the idea behind parallel lines. So we're going to go ahead and say, in each of these blanks, no solution. No solution. So if you see parallel lines, there is not a solution because they never cross.